Hello, cohort 4. It's a great pleasure to work with you again. The purpose of this video is to help you complete your lab for factorial analysis. As you will see in this video, what I have here is I have a student item analysis output that I downloaded from Performance Matters. Within St. Lucie Public Schools, our school district office creates each of our unit assessments for us. And so each of the tests has been master designed to measure specific standards. And usually on one of our unit assessments, it will measure anywhere between 2 and 3 standards. And each question on the test is specifically designed to measure one of these standards. And so on this test, for example, this is a 10th grade English language arts test result. You will see that there are actually 3 standards that this test is measuring. It's measuring 1.1, 2.5, and 3.7 for informational texts. And so there are 10 questions. You'll see that I have removed student names and I've added a student ID number just for the purposes of this analysis. I didn't want to violate any student's privacy. And then what you'll see going across is each student's response to a specific question. So a green box indicates that they answered the question correctly. A red box indicates that they answered the question incorrectly. And a yellow box means that they received partial credit. So the whole purpose of the factorial analysis is to determine whether or not we can statistically determine if items or questions on a test, for example, are related to one another statistically. In other words, if we were to look at the statistical analysis for these questions and try to group them together, could we group the questions together the way that they were intended to be grouped, which are the 3 different standards? And so what we call these is constructs. Is the test obviously measuring constructs? How many constructs is it measuring? Or how does a factorial analysis group these questions together? And are they apparent? Are we able to determine that these questions are statistically grouped in a significant way? If they're not grouped in the way that we expected, it means that we may need to make changes to our questions or changes to our test. And that's what a factorial analysis can help us do. It can help us determine if a question is a fair question or if a question's actually measuring what it's supposed to be measuring. So here we go. I'm going to switch over to SPSS now. What I've done is I already have my data in SPSS, and so I'll go to my data view so you can actually see what it looks like. What I've done is I've copy and pasted the data into the SPSS data editor. I went over to my variable view and I made sure that everything was set up the way that I wanted it in my variable view. I made sure that my student ID numbers are used as not a nominal variable. And then I made sure that everything else was at a scale. As I've explained in other videos, I prefer using the SPSS version that we're using. I prefer to use everything as a numeric type variable, because I've noticed if I use a string variable that SPSS in this version does not handle it very well and it causes problems for me. So to avoid those problems and avoid the headache, I am just using numeric variables to code everything. So when I switch over to run my analysis, I go back to my data view and I'm going to choose Analyze. When I choose Analyze, I'm going to go to Dimension Reduction. And under Dimension Reduction, you should see a submenu that says Factor. Oops. So when you click on Factor, let me reset it so you can see. You're going to move all of your questions over to the variables column. And so I know that all of these questions are my variables. And so I'm going to move them over. I'm going to click on the descriptives box, and I'm just going to make sure that the information that I need is there. I want to make sure that I have initial solution, and then I'm going to click all 4 of these boxes right here. I'm going to click coefficients, significance levels, determinant, and then KMO and Bartlett's test of sphericity. Next, I'm going to click continue. I'm going to click on extraction, And when I click on extraction, I'm going to make sure that principal components is selected. As you can see, there are many ways to do this, but I am choosing principal components. I'm going to make sure that the correlation matrix is there. And then I'm going to look at my eigenvalue to make sure that it's greater than 1. So anything or any construct within this test that has an eigenvalue greater than 1 is going to be selected as a construct. Next, I'm going to click continue, and then I'm going to go to rotation. Now, there are a number of methods that you can choose here. Because I know that I'm looking for 3 constructs, because remember, I have 3 standards, I'm expecting there to be 3 constructs in this test. I'm looking for the program to group questions into 3 different groups, and I'm expecting there to be a group related to 1.1. I'm expecting there to be a group of questions that the program recognizes as related to 2.5. And I'm expecting there to be a group of questions that the program recognizes as related to 3.7. And so because I'm expecting a certain number of constructs, I'm going to choose direct Oblament. If I didn't know how many constructs I was looking for, I would choose Verimax. But once again, because I know exactly how many constructs I'm looking for on this test, I'm expecting there to be at least 3, I'm going to choose direct Oblament. When I choose that, I'm going to click continue. And then I'm going to click on scores. I just want to make sure that everything there is correct. I'm not going to, everything in this area should be unchecked. And then I'm going to choose options. And I'm going to make sure that it says exclude cases listwise. And then under coefficient display format, I want the coefficients to be sorted by size, at least in one of my columns. So I'm going to click continue once I have done that. And then I'm going to run my analysis that gives me my output. The output looks like this. It gives you a number of boxes. Some of the tables we will use, and some of the tables we will not use as part of this assignment. But I am going to go ahead and switch over to my PowerPoint where I have annotated the slides so that way you can have a visual reference as I discuss each of these slides. So what we have here is, I just want to let you know that for factorial analysis, we are doing an independent groups factorial analysis, and Chapter 12 does not provide an example of a result and a discussion on independent groups factorial analysis. The only results and discussion that they provide you with is application 12.2, which is a 2-way between subjects ANOVA, which is a different type of factorial design from the lab that we're doing. So what I would like you to do is you can reference 12.2, but you're going to need to make some slight changes to the wording to better fit an independent groups factorial design. So just know that you're not going to be able to follow it as closely as you followed the other options. I'm just going to go ahead and continue. As you can see, on your output, you will see your descriptive statistics. It will give you the mean response for each of the questions. As you can see, the means actually mirror the averages that were outlined on my existing spreadsheet, so it's very similar. And then you're going to see something called a correlation matrix. And what you're looking at when you look at the correlation matrix is you're looking for any questions that have a correlation greater than 0.9. When you have a question with a correlation greater than 0.9, it means that the questions are too similar, and you may not want to be using one of the 2 questions in your factorial analysis because it could skew your results, and you may not get the analysis or the results that you're looking for because your results have been skewed. So when I look at my questions, I'm going to go ahead and look at the first column. I see that question 1, when compared to question 1 or when correlated with question 1, has a perfect correlation, but I expected that perfect correlation. So I'm not going to throw out question 1 because we're comparing it to question 1. Question 2 does not have a relationship or a correlation greater than 0.9, so I can keep it. 0.005, it's not greater than 0.9, so I can keep it. and so on. As you can see, none of my questions have a relationship greater than 0.9 other than question 1 to question 1. Question 3 to question 1, question 5 to question 1, none of them are greater than 0.9, so I don't have to determine anything greater than 0.09 as being irrelevant for my test or dangerous to my results, anything that could skew them. Next, you're going to see your KMO and Bartlett's test. You can see that you're looking for a KMO score that is greater than 0.6, and this tells you whether or not you are able to conduct a factorial analysis. Because that score is greater than 0.6, I can move on with my factorial analysis. Also, when I look at the sphericity, I can see that there's a significance of 0.000. Because it's less than 0.05, we can continue on with our factor analysis. Again, this table lets us know whether or not it's appropriate, based on the data that we've submitted, to conduct a factorial analysis. And based on the numbers that I'm seeing, this data is an appropriate data set to conduct a factorial analysis. Next thing that I just wanted to show you was a total variance explained table. As you can see, my factorial analysis output shows that there are 3 components that are accounting for 52% of the variance in the model, and the program identified 3 major patterns within the data. Again, I expected there to be 3 constructs, so what this is showing me is that there were 3 major constructs that account for the majority of the variance within the model. And so this is what I expected, and so what I expected is being confirmed. Because I have 3 standards or 3 constructs that are being measured, I expected to see at least 3. And as you can see, they accumulate to 51 or 52% of the variance in the model. So it's the majority of the variance is related to these 3 big ideas that the test is finding, or that the analysis is finding. Here we are, we have a component matrix. Within the component matrix, the higher the absolute value, the greater the correlation to the construct. So as you can see, question 6 has a 0.745 correlation to component 1, or construct 1 is what we're calling it. And so when I go back and I look at question 6 and question 10 and question 7 and question 8, my assumption, or even question 2 and question 9 and question 4, that they'll all be measuring similar constructs. And I know that those questions measure RI 1.1, which is all about finding textual evidence to support. And so I can see by looking at that those questions are all related to the same idea of citing textual evidence. And so they're related. When I look at component 2, this is my second construct that the test found. And again, I'm looking for relationships here, and I know that my greatest values in these columns, as I look at it, question 1 had the highest absolute value, and then I look at question 5, I see that that has a high absolute value, or one of the higher absolute values. And I see it looks like question 7 has a higher absolute value to this one as well. While this question 7 was not scoring what I thought it was scoring, it does seem to be, related, but I do know that question 1 and question 5 were assessing RI 2.5. So it appears that those 2 questions were clumped together, and they were shown to have a high correlation to the second construct. When I look at construct 3 on here, I see that it has grouped together questions 9, 4, and 3 very, very closely. As you can see, the numbers here are very close. This one's a little off, but these 2 are measuring 3.7, and it shows me that I am able to, based on the questions and the responses from the students, it appears that these questions seem to be measuring the same constructs based on the rate of response from the students. And so based on my factorial analysis, I can conclude that the constructs are there.